Assalamu alaikum and hello everyone. This is our last tutorial and it is about waves. Let's first have a concept about progressive waves. Progressive waves are the ones that move, means they progress. So a progressive wave is defined as the wave that propagates. Propagation means movement. It propagates continuously outwards or away from the source of the disturbance, right? So where they are produced means where the source is producing these waves, the waves propagate away from the source. Such waves are called as progressive waves, and the mathematical formula for these waves is this one. It is the similar one that you have studied before, but you can here see the displacement factor here. The k is the wave number and x is the displacement or the distance traveled from origin. Here ym is the amplitude, omega is the angular frequency, k is the wave number, and it is equal to 2 pi over lambda, where lambda is the wavelength of the wave and x is the displacement. So the plus minus sign, this plus and minus sign depends on the direction of the movement of the waves. Okay, so we can use either plus sign or minus sign depending on the direction. So if the wave is moving in positive x direction or just the positive direction, if it is written that in the positive direction, it is understood that it means in positive x direction or along the positive x-axis. Then we use minus sign, and when it's the direction of the movement is in negative direction or negative x-axis direction, then we use plus sign. And the velocity of the progressive wave can be determined using this formula. V is the velocity, omega is the angular frequency, and k is the wave number, or it can also be represented in terms of wavelength and time period. So there is difference between time period and time. This time is any time on the time axis, but this time with capital T is the time period. This is the time that is taken by one complete wave to pass through a certain point. Example number 1, a progressive wave equation is given as, so this is the progressive wave equation or the equation of a progressive wave where x and y are in meters and time is given in seconds, means y is in meter, y is the amplitude or the intensity of the wave, distance along the y-axis, and x is the distance it has traveled from the origin. So we have to calculate amplitude, angular frequency, period, wave number, wavelength, and speed of the wave given by or represented with this equation. So the given data is this one, and from here means we are given the progressive wave equation. From here we can extract all the information that is required from us. So first, amplitude. In order to calculate amplitude, we will compare our given equation with the standard or general equation of the progressive wave that we saw on the first slide. This is the standard or general representation of the wave equation of the progressive wave, and this is the one that is given to us. So when we compare this, we can get the value of our amplitude. How? Because in the standard equation or the general equation, ym represents amplitude. So on the same place in the given equation we have 5, so ym is equal to 5, which is the amplitude. Therefore our first answer is already obtained. Ym or amplitude is equal to 5, and it should be in meters. Okay, so the units are important to mention here. So you have to mention the correct units, which are meters, as you are told in the statement that y and x both are given in meters. Okay, next, angular frequency. Again, we will compare these two equations, the standard or general equation and the one that is given to us. We will compare them both. We already seen that ym is equal to 5. Now here we will look into inside the bracket, the terms inside the bracket. Omega is the angular frequency, right? So on the same place here, since it is omega t, here it is 2 pi t. So omega is equal to 2 pi. Just by comparison we can find this value. Therefore angular frequency is 2 pi radians. Now the third is period. Period is actually the time period. So time period is represented like this. The angular frequency is equal to 2 pi over t, where t is the time period. Since we have found out already that omega is equal to 2 pi, t can be obtained from this formula by inserting the value of omega here. In a very simple way, we rearrange these terms to derive the value of t here. T comes here and omega goes there. T is equal to 2 pi over omega, and then we insert the value of omega here, which was 2 pi. So 2 pi divided by 2 pi is equal to 1, and time is given in seconds. Okay, so the time period of the given wave, the given progressive wave, is 1 second. Next is wave number. So in the standard equation form, k is the wave number, and when we compare it with the given one, so we can easily get the wave number, which is pi. Next is wavelength. Since we know that pi, as if you go back to the first equation, you will see that k is equal to 2 pi over lambda. Here lambda is the wavelength. So we rearrange terms to derive the value of lambda. Lambda is equal to 2 pi over k. Now we substitute the value of k here, and we get 2 pi over pi. Pi cancels out the pi. Pi cancels out pi, and we get lambda is equal to 2 meters. Because the distance was given in meters and lambda is also distance, so it should be equal to 2, and the units must be meters. Now in order to calculate speed of the waves, we have to refer back to the formula given on the first slide and simply insert the values that we have obtained in the solution of these problems. Lambda divided by time period. This is lambda, and time period was obtained on the previous slide, which was 1 second. So we simply substitute values here. 2 meters divided by 1 second, it gives us v is equal to 2 meters per second. So this is the speed of the waves. So very simple. You had to find out 6 variables here, which were very easy to obtain with all the formulas given on the slide number 1. Okay, now move to example number 2. In example number 2, a wave traveling along string is described by this equation. So this wave is in the string. In a string means, for example, you have a string, you tie its one end with a wall, hold its other end, shake it up and down, and you generate a wave in that string, and that wave is represented with this equation. In this equation, it is you can compare it with the standard form also. So the term that is given before the sine function represents amplitude. The one inside the sine function, there are usually two terms. The term which has t or time with it, that is the angular frequency, and the term which has x, with it, that is the wave number. Okay, so in this equation, the numerical constants means this one, and this one are given in SI units or system international units. That means 0.00327 meters is the amplitude, 72.1 radians per meter is wave number, and 2.72 is radians per second is the angular frequency. And you have to this one has 4 parts. First one, you have to calculate, you have to find out the amplitude of this wave. It's very simple. Clearly this 0.00327 meters is the amplitude, and the wavelength, period and frequency of this wave exactly the same way as we did in the previous example, and velocity also as we did in the previous example. The last one is what is the displacement, the y value, this one for certain values of x and t which are given here. So this is the different part, but also very simple to solve because you are given the value of x and t. You put the value of x here and t here, you will get the value of y at that certain value of x and t. So I will I will describe only the part number D, while all others you will have to do yourself, but I will give you the solution in the next slide. So solution will be given to you, but I will describe only part number D. In the given data, you are given the equation of the progressive wave which is generated in a string. So part A is the simplest one. Part B, you can understand it well. Once you do the example number 1, then you will be able to understand it very nicely and easily. And part C also, it is simple. In the in example number 1, we used the formula. There were 2 formulas shown in the slide number 1, right? So one was omega over k and other was lambda over t, lambda divided by time period. So in example number 1, we used v is equal to lambda over time period. Here, because we are given the value of k and omega, we will use this formula. Okay, so you can use depending on the information that you are given with. And the part D, you have to calculate the displacement of the string at a distance 22.5 centimeters from the origin and at time 18.9 seconds. So you will simply put these values in equation number 1 here. Okay, once you put these values here, you perform the calculations, and inside means this one 72.1 is the value of k, and this 0.225 was the value of x that was given to you, and 2.72 is this one, and t is the value that is given to you for part number D, 18.9 seconds. So you calculate these, perform apply sine function on it, multiply it with the amplitude, and you will get the displacement 1.92 millimeters at this displacement or at this distance from the origin and at this time 18.9 seconds after the wave was generated. Okay, next 3, you are again given the equation for the progressive wave, this one, and you are told that all the units are expressed in SI units, and you have to calculate following things. Number 1, frequency of the wave. Number 2, phase difference between 2 positions of the same particle at the time interval of 0.25 seconds. So 2 positions of the same particle. Same particle means that the particle which is moving in the medium. You know that the mechanical waves, when they pass through a medium, they move particles up and down or to and fro. So this one is the sinusoidal wave, means that particles will be moving up and down, and the wave will be traveling in positive x direction or negative x direction. So the particle that is moving up and down, we have to find out the phase difference between its positions when the time interval is 0.25 seconds. Means in quarter of a second, what is the phase difference which will be generated in the position of the particle. Okay, means how much will be the difference in the phase. And lastly, the phase difference at a given instant of time between two particles 50 meters apart. So there is a wave, there will be many particles oscillating up and down along the wave. So we have to find out the phase difference at a particular instant of time. For example, maybe 1 second or 1.25 seconds. At that instant, two particles which are 50 meters apart from each other, means one particle is here and another particle is here. So we have to find out the phase difference between those two particles during the movement. Again, we are given only the equation of the progressive wave. Let's start doing it. So here, this is the equation that is given to us. To make it simpler and easier to compare with the standard equation, we multiply this 2 pi inside the bracket here, and we get this value. And now we can easily compare it with the standard form, because the standard form has this 2 pi inside the equation, inside the bracket, and not the outside. First, we calculate frequency of this wave. So we compare it, this equation with this general one. This is the general one and this is the given one. When we compare it, we can get omega as 2 pi, because this one omega is 2 pi, omega t, and 4 pi t means omega is 4 pi here. And a similar way, k will be 0.02 pi. Okay, so x, both are same, so the term before x will be k. So, likewise the term before t will be omega, right? So by comparing these two equations, we get omega, which is 4 pi. But this is angular frequency, right? We have to find out frequency, and we know that angular frequency is equal to 2 pi over time period, or we can write it like this, 2 pi f, because we know that f is equal to 1 over t. So 2 pi over t becomes 2 pi f. Now we derive the value of f from here like this. We insert the value of omega, which was this one, 4 pi, and we calculate it equals to 2. Therefore the frequency of this wave is 2 Hertz. Next is the phase difference between two positions of the same particle at the time interval of 0.25 seconds. The same particle, it is oscillating up and down. So between two times, for example, this time can be between 1 second and 1.25 seconds. So the time interval between the two is 0.25, or let's say between 4.2 seconds and 4.5 seconds. The time interval is 0.25 seconds. So we have to find out the phase difference between the position of the particle between the time interval of 0.25 seconds. Phase difference is represented with this formula, 2 pi t over capital T. So this is very similar to this formula, omega 2 pi over t, just one t is added here. Okay, so if you multiply it with the time, this omega becomes the phase, and 1 over t is equal to f. We can write it in this form, 2 pi t f. So now we substitute values of the f and t. The time difference is 0.25 seconds and frequency is 2 hertz. So in 2 pi as it is, t is 0.25 and f is 2 hertz, right? So now do the calculations and we get phi, or the phase difference, is equal to pi hertz. The phase difference is the phase difference is pi radians. Okay, example, we have to calculate phase difference at a given instant of time between two particles which are 50 meters apart from each other. So the time is the same, there is no time difference, but these are two different particles. Between them the distance is 50 meters. So the phase of the propagated progressive wave of wavelength lambda means a wave that has a wavelength of lambda with respect to displacement, means the formula with respect to displacement is given as in the previous part of this example we use this formula, and it is also equal to 2 pi x over lambda. We do not need to go into the derivation, you just can memorize it. So small t is replaced with small x, or the distance, and capital T is replaced with wavelength. So these both are times and these both are distances. T is time, capital T is time, x is distance, and wavelength is also a distance. Now we know that the wave number is represented as 2 pi over lambda, and from the given equation we know that k is equal to 0.02 pi. So the wave number will be equal to this one. From here we can calculate the value of our wavelength that we need to put in equation number 2. Now we put the value, we rearrange the values, we rearrange the terms to find the value of lambda. So lambda is equal to 2 pi over k, and the value of k is 0.02 pi. Okay, so we rearrange the terms, lambda comes here, 0.02 pi goes on the other side, and we perform calculations and we get the value of 100 meters. This is the wavelength of the wave, and then we will substitute the values of x and lambda in equation number 2, and the x was given to us, which was 50 meters. We'll put that value here, means in this equation here 50 meters, and divided by 100 meters, which was the wavelength. We perform calculations and we get the phase difference of pi radians. So the two particles which are 50 meters apart from each other, they will have a difference of pi at a specific instant, or at any instant of time. They will be moving out of phase by pi radians. In example number 4, a plane wave is traveling in the direction on the surface of water. So there is a wave that is traveling on the surface of water. That direction is not told to you. If the positive direction of x coordinate is regarded same as the traveling direction of the wave, the displacement y of the surface is at that of the water surface at that point x, and at time t can be represented like this. So if the positive direction of x coordinate is regarded as the same as traveling direction of the wave, the displacement y is given like this. So now you are told that in this equation of the wave which is traveling on the water surface, these constants a, p and q are all positive. Okay, their values are positive, and the ratio of the circle circumference to its diameter is pi. Okay, you know that what is the circumference and what is the diameter. 2 pi r is the circumference, and two pi r is the circumference of a circle, and 2r is the diameter of it, right? So if you divide them, you will get pi. So 2 pi r divided by 2r is equal to pi. So this is a way of expressing it. Okay, and you are asked to calculate in part A the direction of the wave. It is positive or negative. You have to provide reason why you think that it is moving in positive x direction or in negative x direction. And in part B, you have to calculate the frequency, wavelength and speed in terms of A, P and Q. And the part B is very similar to the ones that we did before. Okay, in the given data, we are again given only the equation for the wave. In part number A, since we have to explain our answer, we will actually, what we are going to do is first we derive an expression for the movement of the wave, and then on the basis of that we will decide it is moving in positive x direction or negative x direction. So let us consider that the wave travels a distance of delta x during a time interval of delta t. So we are assuming that the wave which is given by this equation travels a distance of delta x meters in a time delta t, in the time interval delta t. Then we can write this equation like this: after that time interval delta t, the wave has moved to a new position, right? So the time has increased from t plus delta t, and the distance has been changed from x plus delta x, because the this time has been spent and wave has traveled by this amount. Now for progressive wave, the amplitude does not change, and also the terms which are inside the sine function do not change as the wave moves. Therefore we can write that this term pt minus qx, which was before the movement started, okay, before this delta x delta t time started, and this term after delta t time has ended. So these both terms are equal. pt minus qx must be equal to this term, okay, because during the movement the terms which are inside this sine function do not change, and also amplitude does not change either. So considering that, keeping that thing in mind, we can equate these two terms to each other. This one is before delta t, or just before delta t started, and this is just after delta t has ended. So this is one, and this is the second one, before movement and after movement. So this thing does not change. We can equate both of them. Now we will rearrange the terms. After multiplication, we multiply this p in the bracket and q also in the bracket, we get this one. So pt plus p delta t minus qx minus q delta x. Now pt cancels out this pt, and minus qx cancels out this minus qx, and we are left with 0 on the left hand side and p delta t minus q delta x on the right hand side of the equation. Then we rearrange the terms again. We send this on the other side and then divide delta x by delta t, right, which becomes equal to p over q. You can rearrange the terms and then try to find out this expression. This is very easy, you can do it. And also you will realize that delta x over delta t is a certain term, right? Can you guess? This is the velocity, okay, distance divided by time. Okay, so p over q, these are positive. How do we know that this is positive? Because in the question it was given that, okay, p and q are positive values. So since both of these are positive values, we can easily say that this term is greater than 0 or it is positive. Therefore we can say that the given wave is traveling in positive x-axis direction. Okay, the part B, first we have to calculate frequency. We will compare the given equation 1 with the standard equation again, and we know that in the sine function the term with t represents omega, right, and the term with x represents wave number, right. So p is omega is equal to p. Again, now we know that p omega is equal to 2 pi over t, and 1 over t is equal to f, so we can write it like this. From here we can rearrange terms and find the value of f. Okay, this is the value of f. It is in terms of p. Okay, next we have to calculate wavelength. Again we will compare our equation number 1, which is the equation of the wave given in the statement of the example. Now we know that the term with the x inside the sine function represents the wave number, means wave number is equal to q here, and also we know that wave number is equal to 2 pi divided by the wavelength. From here we can rearrange terms and find out the value of lambda. So lambda is equal to 2 pi over q. Again we were asked to calculate and find the values in terms of a, p and q. So lambda is equal to 2 pi over q. Next is speed. To find out speed, we will have to refer back to part A, in which we showed that delta x over delta t is equal to p over q, and delta x over delta t is the speed, right. So distance divided by time is equal to speed, or s is equal to vt, or v is equal to s over t. You remember the formula, right? So this is equal to speed, so we can simply write that speed is equal to delta x over delta t, and delta x over delta t is equal to p over q, because we have to find out answer in terms of a, p and q only, right. So this is our answer for this part of the question. Our last example, this is a very simple and easy one. I am not giving any statement of the problem here. I will just show you one wave. This is a sinusoidal wave. You can extract a few informations from here. First you need to look at the axis. So this is y-axis, it shows the vertical displacement, and this is x-axis. X-axis are of two types. One is the distance, and the other is time. This one is distance, it is representing distance. Okay, so and this one up and down oscillations of the particles of the medium, and this one represents distance because it is on the distance axis. And the maximum height that this wave attains is the amplitude. So this wave has an amplitude of 1.5. okay, it goes below and above. So 1.5 on the top, minus 1.5 below in the negative side of the y-axis. This 0 is the origin. On the left side of it is the negative x-axis, on the right side is positive x-axis. So the top one is called as crest and the bottom one is called as trough. Okay, now if you are asked to represent this wave on time axis, how you will do that? Because here the distance is starting from here, that's why it is 0. So this is the origin. From here the distance is starting, but time is not starting from here. Time starts when the wave starts. So time should start from the point here, right? So we will draw same axis, same sort of axis, but the horizontal axis will be time now. So instead of x it is t, but the vertical axis is the same. Okay, so now the shape of the signal, the shape of the wave is exactly the same. The only difference is that now it is starting from here, right? Earlier it was starting from here, now it is starting from here. This one should move forward to the origin of the time, so that it starts from time 0. okay, the amplitude remains the same. From this one, from the wave represented on x-axis, you can determine the wavelength, right? So wavelength is the distance between two consecutive crests or two consecutive troughs, or we can also measure from here until here. This one represents the length of the wave, because one wave consists of one crest and one trough. So the by definition the distance the wavelength is actually the distance between two consecutive crests or two consecutive troughs. Okay, and on the time axis, if the wave is represented on the time axis, then you can measure its time period, or the time taken for one wave to complete. Means that the time difference or the time interval between two crests or between two troughs, that is the time period. Okay, so you can obtain different informations depending on the representation of the wave, on what type of axis it is represented, right? Okay, and that's all for today, and that's all for this semester as well. So as always, if you have any questions, you can contact me and ask your questions anytime on Kaizala, or yes, we are not going to have any live session now, so you can ask me as you like, and wish you all the best for your exams and have a good one.